In this video, I'm going to be outlining the basics of using an infrared remote control to send output to an infrared receiver that you can then read through your Arduino, and then use that output from the remote to control an RGB LED. There's going to be two sections to the video, the first being a basic reading the output from the infrared remote through the IR sensor and displaying the output, and then the second piece of code, a little more complicated, actually controlling the RGB LED and using the liquid crystal display module to interactively change the signals being sent to the RGB LED and be able to see it in real time. So I hope you enjoy, and here we go. Okay, here as promised is the first of the two programs. This one is little more than a basic routine that I wrote to read the input from the remote control and display the output through the serial monitor so that I could see what keys were being pressed and what hex code was generated. Now I've already built a array here of the 21 keys on the remote that you saw there at the beginning of the video, which is the one that came with my little Arduino starter kit. And I've also stored in an array the strings containing the actual button that was pressed. So basically the program, I do want to note here before we begin that the infrared library that came with, at least with my IDE, did not work properly, would not allow the programs to compile. So I ended up removing the IR remote library that was stored in robot IR remote in the C:\program files Arduino libraries. Actually temporarily moved it to the desktop and then downloaded from GitHub, actually by the same author of the library that's sent with the IDE, and unzipped it and put it in its place, and everything seemed to work fine after that. So the basic mechanics of the program: the infrared receiver has 3 pins, plus 5 volts ground, and then the receive pin. So I've connected the ground to ground and the 5 volts to 5 volts and the receive pin to pin 8 on the Arduino. And basically the program, after defining those arrays, I initialize the infrared library, define the variable that the output's going to be stored in from the remote, and then set up the serial monitor and start the receiver. Then it just loops through, looking for input, waiting for input from the remote, displaying the raw data, and then showing you the corresponding key that was pressed. Now the remote, at least the one that I have, also sends appears to be a termination string, which is always a string of F's that I didn't need. So, and the string of the contains the key presses also had a leading FF at the beginning. So I used this line here to just filter out that FF, and then to differentiate between what was left and one of these termination strings, I just checked that the string is smaller than FF in hex. Then it simply displays the key that's pressed and just loops back around waiting for the next key to be pressed. So if we upload this program to the Arduino, I don't know why we're taking so long. There we go. Open the serial monitor. Open the serial monitor. There we go. And then when the buttons are pressed, like if I press the power button, you see there's the string. The A25D matches, this matches right here, matches my power button, and next button is mode, next one is a mute button, And you can see the termination string as well that it's putting on at the end. So I just wrote this program to make sure I had a basic understanding of how to read the signals being sent by the infrared remote and filter the output for my purposes. So, I can press a number of keys and it will show me each time there's 0, plus, minus, the play, pause button, the mode button, whatever key is pressed, 5, whatever it is. And then it just loops through, displaying those each time. I didn't do a whole lot of remarking of the source code here because it's pretty self-explanatory, and I did go into a little more detail with the second program, which I will show you here in a minute. And here's the second program, which is a little more complicated. It takes the input from the remote control and uses that to allow you to interactively change the red, green, and blue signal of the RGB LED. And I also did connect a liquid crystal display to the Arduino for the purpose of seeing the output and interactively changing the colors. So this program is a little more complicated, and I did put a few more remark statements in here as well to make it a little easier to understand. And again, as I mentioned before, the default IR remote library did not work, and I replaced it with the one that I downloaded from GitHub at this address here. And of course I will include these addresses in the comments for this video as well for your convenience. So basically, I only used 5 of the buttons on the remote for this particular program: the power button, the mode button, the play and pause button, and the minus and plus buttons. Now once the program is initiated and running, pressing the power button on the remote will cycle the LED on or off. Pressing the mode button will cycle the display through, allowing you to adjust the red, the green, or the blue signals being sent to the RGB LED using the plus and minus keys. And then pressing the play/pause button will return it to the I guess you could say home screen, where it shows you the RGB values that are currently set for the LED. So there again, here we're including not only the infrared library but the library for the liquid crystal as well, because like I said, it uses the liquid crystal display. I've defined the pins being used for the red, green, blue LED, the pin being used by the infrared sensor, and the pins being used to drive the liquid crystal display. Now note that these are non-standard pins. For whatever reason, I had some issues with my Arduino not using pin 11 as a PCM pin. I wasn't able to send analog output to the RGB. I originally had it set up at 9, 10, and 11, but I swapped out 6 and 11 and used 11 on just for a digital pin to drive the display instead. So these are non-standard, but of course, they're all arbitrary. You can use whatever pins you choose, as long as the 3 pins for driving the RGB are connected to PCM outputs on the Arduino, or otherwise, it's going to be on or off. So basically, we've defined those pins. We've started up that liquid crystal library and the infrared library. Now here, the liquid crystal display does allow you to define your own custom characters. So I created one for the pause and play button and another one for the power button. Now in the segment of the video here that comes later, we'll actually show you the output from the on the display. You'll be able to see those custom icons. Here again, I've defined in an array the hex values that are assigned when you press each button on the remote. And there again, the remote that you choose to use may have different hex values than this, and you'll have to use a program similar to the one I showed you earlier in the video to determine the values that are generated when each button is pressed on the remote. Now there's no longer any need for me to have the actual text values for the buttons used by the program, but I did include them in a remark statement underneath each so that you could see, what key is being pressed. Now I also declared an integer value so that when I'm cycling through the red, green, and blue modes to adjust the value, it allows me to keep track of which one is currently selected. And I did store red, green, and blue as text in an array. It's used by the program to simplify displaying which one of the three is being changed without having to generate the same piece of code 3 times. The value of the key variable is used to match up the key that was pressed to the particular key in a case statement, which I'll show you here in a minute, so that it's basically a pointer as to which button was pressed on the remote. Now I just stored default values of 128, 128, 128 for red, green, and blue in a variable or in an array called RGB. And this in the program, actually we use this RGB array to store the signals that are going to be sent to the LED. A couple of flags to indicate whether or not I've turned the LED on or off, or whether it's in the color changing mode, or I guess what you could call the home mode. So the setup basically defines those pins, starts up the display, starts up the receiver, and assigns those 2 custom characters that I defined in binary up here sends those to the display. Alright, now I turn the LED on and then call the routine that displays the RGB values, or sets the RGB, displays them on the display. Now these 2 subroutines are down here at the very bottom of the program. The one that shows the values is the one that shows on the display what the current RGB is. You can see array sub 0 is red, array sub 1 is green, and array sub 2 is blue. And this other function here, this other subroutine, it actually writes the signals out and sets the colors in the display. So by default, it defaults to 128, 128, 128. So it'll be basically a white LED at half brightness. So the actual looping part of the program is very similar to what you saw in my previous program. It filters out that termination string that's being sent, and also chops off the first 2 bytes because they're unneeded. Only these last 4 actually contain the data from the remote. And again, it may be different for if you're using a different remote than I was. So at that point, once it has received input, it basically cycles through the array up here of possible key presses, and if it is indeed a match, then I use this case statement to tell it what to do if each key is pressed. If it's the power button, if the power is currently on, it sets the flag to turn the power off, takes it out of the color setting mode if it was in it, sets all the signal levels to 0, and displays on the screen that the LED is off, and tells you to press the power button. Here's where that custom character 1, which is the power button icon, is displayed to indicate I apologize, it's down here. It's custom character 2 is the power button, and it'll display that little symbol. I'll show you that here in a minute when we get to the actual showing how it works. Otherwise, if it was off, it turns it on, sets the LED to the values that are currently stored in RGB. Now, of course, if it's just being cycled on and off right after the program's run, there's still going to be 128, 128, 128. Otherwise, whatever values have been stored in there by changing the signal levels will be stamped back into, or sent back to the LED and displayed. So if the button pressed is the 1, which on my remote happens to be the mode button, it sets it into color setting mode or changes the flag, and cycles through each time you press it, whether it's setting the red, the green, or the blue. And that's all it does. A break statement here just ends the case statement, and then it loops around waiting for the next key to be pressed on the remote. Now if the play button is pressed, what it basically does is take whatever values are currently stored in RGB in that array and sets them in the display, or sets them in the LED and displays them on the display. Okay, case 7 happens to be the minus key on the remote. That allows you to lower the signal level for whatever color you currently have selected all the way down to 0. And if you press the plus key, it's going to flag as an 8, which is the adding to the button. In both cases here, it's increased by 16 or decreased by 16, because increasing or decreasing them by 1, it would take forever to change the brightness on that LED, and you would hardly be able to see the difference. And there again, I don't allow it to exceed 255. That's the maximum it's going to be. So basically those are all the buttons that it has to look for in this particular program. And then if it's in color setting mode, it updates the display and sets a new level on the LED, and then it just loops around waiting for the next key press. It's really pretty straightforward. Alright, so at this point now I'm going to show you the actual output here, and we'll go from there. Okay, at this point I'm actually going to get the camera out and show you the actual output on the liquid crystal display and what happens when you press the keys on the remote. Okay, at this point I'm actually going to show you the output on the display using the camera and what happens when you press the buttons on the remote. Alright, and here is the second program loaded into the Arduino. I have a little better lighting over here, so I've actually switched the Arduino over to being run on batteries so that I could move it around independent of the computer. I've already uploaded the program to it and started it up, and as you can see, you have there's the infrared sensor and the multi-color LED, the RGB LED plugged in there, and the liquid crystal display over here, which is currently displaying those default values of 128, 128, and 128. So, basically, using the remote here, you can see that if I press the power button, it turns the LED off and changes the display to saying LED off, press power, and there on the display you can see that little custom power icon that I made. And if I press it again, it turns the LED back on again with whatever values are stored in there. Now if I press mode here, it switches over to a screen where it says red level, currently 128. You can see the plus and minus, and then the other custom character that I made, the little play symbol there, stores the value. So once it's in that color setting mode, I can press plus or minus on the remote. See, plus increases the level of red, and you can see it's getting red, or my hand there is indicating that it's up to 255, or repeatedly pressing minus eliminates the red entirely down to 0. So we'll put it back up here around 128 or so. If I press mode again, it cycles to green. Press it again, it cycles to blue, and just cycles through those three. And at any time I can press the play button and it'll return back to, I guess, what you should call the home screen there, where it shows the current values. So let's press mode again. Let's go to the blue level, And let's take the blue out, since this camera seems to have a lot of blue in it. We eliminate the blue. There, now it turns a beautiful green color. Now I can go to the mode again, switch it over to green by repeatedly pressing pressing mode, and eliminate the green, and we get just the red. Press mode again, we'll cycle over to red. We can increase the red all the way up to 255. It looks kind of white on this particular camera, but it actually is quite red. You can see the, alright, you can see it on the back of my hand there. And of course, whatever values I've set now, when I am done, I can press that play button, and it'll return back the current value. You see it's currently set to 255, 0, and 0. So if I wanted the LED to be all green, I could go back to mode, press mode, crank the green all the way up to 255, cycle over to blue's already at 0. I could lower red down to 0 and get an intensely green LED. Now, of course, I just chose to jump it in steps of 16. You could step it in units of 1 if you chose, or for whatever purpose you had for controlling that LED in whatever increments you wanted. But this is a basic example of how to use that nifty little infrared remote, or any infrared remote, if you go through with that first program that I showed you to in order to interpret what buttons translate to what hex codes. Then it's just a matter of reading the hex codes and making the program respond correspondingly to those key presses. I'm going to press power one more time here. Bloop, turn it off. You can see when I turn it back on, it'll default back to whatever values were set in there before. Just repeatedly pressing it on and off, turns it on and off. I go back to mode, set it to red, increase the level of red. Red just doesn't show up very well on this particular camera. But there's an example, and I hope that you found this useful. Now, I will include links to both programs and source code, as well as the GitHub library for the infrared library, in case you too have difficulties making the one that comes with the IDE work properly. Well, I hope you found this video useful. I do understand that my skills here in explaining things aren't what they could be. I'm still trying to get things started here, but I hope it all made sense. So until the next video, this is King Beetle saying enjoy, and certainly click subscribe if you find this of value and want to encourage me to make more videos on using different sensors or servos or whatever you'd like to see, and I will be more than happy to oblige.